Okay, good morning everyone. So, our topic for this morning is about linked lists. So, this is another type of data structure, still list, just like an array. But before we proceed with linked list, let us first determine the the limitations of an array. So these are the limitations of an array. Number one, changing the size of the array requires creating a new array and then copying the data from the array with the old size to the array with the new size. So ang iyahang mean is kung nakahinumdum mo na atay array, for example, let's say list, and then if ever na full na ang ato ang array, so example 5 3 4 6, and then because it's already full, and remember that the array is a fixed length data structure, so in order to still kanang accommodate the elements for our list, we have to make another array. So for example, temp, and then you double the size of the array. For example, so this is 0 1 2 3 4 5 and 6, and then transfer all the elements. You have 5 3 4 and 6, and then after that you let the reference list point to where temp is pointing. Okay, so that is what meant by the first limitation of an array. And then inserting an item inside the array requires shifting some other data in this array. So if you still remember the shift left and the shift right that we were doing. Okay, so let's have now the link structure. When we say link structure, it is a collection of nodes storing data and links to other nodes. So, it has nodes, diba? It has nodes, and then there could be a type of linked list nga there is a reference on the other node, only one reference na asay linked list nga na siya reference to the left and na siya reference to the right, and then you have the info. Ayan. So for the first one, duha ka bukihang attributes. The first one is the information of this node, and then a link to the next node. And for the other one, you can have a node which has a link to the left and a link to the right, and you have the info also for this node. So nodes can be located anywhere in memory, and passing from one node to another is accomplished by storing the references to another nodes in the structure. So mato siya, no? You have a node stored for this reference. So it can be implemented in a variety of ways, and most flexible implementation is by using a separate object for each node. So you have, okay, one object, another object, another object, another object, and you can link them. And so for your link, or for your linked list, much better if you have a reference for the head and of course for the tail, because if you have only the head and you don't have the tail, then removing or inserting an element at the tail requires you to always begin at the beginning. And if you have millions or millions or 1 million records, you have to start from the first node going to the millionth node. Okay, so there should be a tail. So what is a singly linked list? Because we have two linked lists type. We have singly and we have doubly. So a singly linked list is a data structure composed of nodes, each node holding some information in a reference to another node in the list. So ang iyahang mean is this is a node, and then you have the information and you have okay, you have the next. So ang imuha baling node, ang imuhang node bali kay na siya info nga attribute, and it has also the next reference to the other node. So a node contains a data field that is a reference to another node. Okay? So example, this is your node. Okay? Let's name this head. So it is referencing to the other node. And so many nodes can be strung together using only one variable to access the entire sequence of nodes. So example, you have only one variable, you have head, and then you would like to access this one and the next node, so you simply write head, and the other one is head at next. Okay, so node has a link only to its successor in its sequence. So sara iyahang padulungan, no? Usara, one way ra siya bali. So this is your node. It has a link to the next node, and a link to the next node, and a link to the next node, and the last node is pointing to null. Okay, that is for the singly linked list. So a node has two fields in singly linked list. It has the info, and it has the next. Okay, so this is an example. This is your reference. Let's say the reference is named P, and it is pointing to this node, and then this node is pointing to the next node, and so on and so forth. If you would like to get the value P, you simply P.info, and then for the next one, you say P.next.info. Okay, you write P.info, and then this one is P.next.info, and this one is P.next.next.info. Okay? So, the info field is used to store information, and the next field is used to link together nodes to form a linked list. So, let's have first the insertion. So, when we insert element in a linked list, pinaka-better nga insertion is actually the add first. Kadtong ari ka mag-insert sa beginning. Okay? By doing this, when we say add first, is you have the node, for example, tapos duha panalitan imong references, we have head and tail. So, ang first node nga ma-create kay head and tail na siya at the same time. And if this is pointing to null, then if you insert another node, so the new node will point to this node, which is the head, and then your head will now hold this new node. So again, if there is another node created, the new node will point to the head, and then head will hold the new node. Ingana ang pag-insert. If the insertion is done at the beginning. Pag insertion is done at the tail, so you simply write tail that set next, for example, and then whatever is the new node. So kanina sad imuhang pa guniton sa new node. So the node's info field is initialized to a particular integer. That is if our data for this linked list is or are integers. So the next node becomes a reference to the first node on the list, that is the current value of the head. And then a new node precedes all the nodes on the list. Head is updated to become the reference to the new node. So muna siya to ang ibuhat diri, no? So first kay head and tail pa na siya nag-point sa first node, and then your head is now pointing with a new node, and so on and so forth. So it is only the efficiency of this operation is actually only O of 1. Okay? So ayan, inserting a new node at the beginning. So katong ato anang i-mention kaganiha. What about if you would like to delete a node from the beginning? So if you would like to delete a node from the beginning, you simply what? For example, your head is pointing to the first node, and then you would like to delete the first node, simply let the head point to the next node, and then disconnect the first node. So how to do that? You write, okay, head receives head dot. Before you do this, much better if you should have a reference that will hold first the head. So For example, let's have here temp points to the node pointed by head, and then head will move to the next node. So you're right, head receives head dot next. So head is pointing here now, and then disconnect the first node. So you simply write temp dot next receives null. Okay, that's it. And then deleting a node from the end of a singly linked list. So how to do that? You have to begin from the beginning, because one way raman siya, di ba? Ang next niya is nag-hold raman sa iyahang kanang um, successor. Is it successor? Ayan, to its successor. And then, okay, so pag mag-delete ka mo na siya, you have to begin from the beginning. And then, once nga, ang imuhang temp, di ka na dapat mo abot sa tail, no? Ang imuhang temp should be up to before the tail. So, dapat ang imuhang checking ani kay while your temp that next is not equal to null. So, pag dili pa gani, you move the temp. So, your right temp receives temp dot next. Okay? So, once nga ang temp dot next is already null, so that's the time nga mo stop na ka. So, with that, na-dere si temp. Nagunit. And then, by that, mayroon kag temp dot set next. If it is a method, you write null, for example, or you write temp dot next is equal to null. So the tail now is disconnected. But make sure before you do that, your tail should point here. So you write tail receives okay, tail receives temp. Hinga na. Para dili na mo gunit si tail. Balik. Kay disconnected naman ni siya nga node. So, removing the first node of the list with at least 2 nodes requires updating head, and removing the last node of the list with at least 2 nodes leading to the update of tail. An attempt to delete a node with a number that is not in the list, simply do nothing. When you search an element in a singly linked list, simply scan an existing list to learn whether a number is in it. So, begin with the reference head going to the tail. Okay, so that's it. These are the, with reasoning, very similar to that used to determine the efficiency of delete is in list. It takes only O of 1 time in the best case and O of n time in the worst and average cases. So it's fast compared with array. Okay?